still coming, or they have lost it in earthquake? Please. Yeah, so we'll begin with earthquakes today, but while we begin it, I'll in this particular session I'll be needing at least 3 volunteers with me here. Okay, so whoever has that kind of courage that okay, you would not want to be scared when you're coming here and sharing the stage with me, you're very welcome. I'll need 3 people while this particular class to demonstrate a few things. Okay, so it's up to you who does that. Okay, because you are going to be pulled and pushed a lot. So that is no, that is serious. I'm serious. You'll have some amount of pulling and pushing. That is going to happen today. And where is my mechanical engineer? I needed him. He's not here. I'll have to make do with my civil engineer then. So today's session is basically on earthquake. Okay. So when required, at least the guys you have to volunteer. Okay. I cannot say for the girls, but guys you have to volunteer because I have some things to actually tell to the students here. Okay. We'll be demonstrating a few things what you're going to learn now. Till yesterday we discussed about the various layers of the earth. Okay, we discussed how you can say the states of matter changes from solid to liquid, then again to solid, then to liquid, and then to solid. Okay, when you go from crust to core, we understood the variation of temperatures as temperature, pressure, and density. Then subsequently we talked about how you can say the various layers behave. Today what we are going to do is that how were these layers determined to be of solid or liquid in state is something that comes from seismology. Okay, so seismology is actually the study of earthquakes. Okay, so as recently as 13th of March, we had an earthquake of about 6.5 Richter scale magnitude in Chile. Okay, so when we talk about this, so earthquakes are a very regular phenomenon. It is not something which happens once in a lifetime. Okay, earthquakes of various magnitudes and varying magnitudes keep on happening all through the year. Okay, some of them are strong enough to cause destruction. Most of them are strong enough to cause significant amount of shaking, but not significant destruction. Many of them, which are the most frequent ones, are the ones which happen continuously, have some amount of you can say shaking on the ground, but they do not cause any significant kind of scaring. Okay, so that is basically what we see as the frequency of earthquake. So today when we discuss earthquakes, okay, so we have to first of all understand what exactly is seismology and seismic wave. So seismology, as I told you, is the study of seismic waves, and seismic waves are actually the way in which energy is produced, okay, during an earthquake. So see, when you talk about energy, energy needs to be dissipated. Okay, energy cannot be created by us. It can only be transformed from one part to the other. Okay, so this is basically the first law of first law of thermodynamics, for that matter, conservation of energy, conservation of mechanical energy, whatever would you want to call it. But it basically says we cannot create energy. Okay, one part of energy or one kind of energy can transform into some other thing. For example, he just coughed. Okay, so when he coughed, actually there was some amount of congestion which was there in his throat. Okay, so when that came out, it actually manifested as shaking of his body. Okay, so when you cough, you actually shake your body. Okay, your ribs shake, and when you are prolonged having that particular cough for a long period of time, your ribs start paining. Why does that happen? Because that particular energy is giving rise to a motion, that is the up and down motion of your body. Okay, similarly, when you talk about when you wink your eyes, okay, so when you're winking your eyes, what basically happens? How many of you have undergone eye tests here apart from the ones who have specs? Anyone else? So what basically happens is that when you are going for an eye test, you might be seeing this, that they basically measure something called as the pressure of the eye, okay, or the eye pressure. How many of you know this? That there is a kind of balloon or a kind of laser that they actually point on you, and then an image comes on in front of you. Have you noticed this? This is one of the things that happens. Okay, so that actually measures the pressure of your eye. That is what keeps your eyeballs in constant shape. That is as a ball. Okay, so in the world, when you talk about any kind of physical setting that you're right now seeing, it basically means it is in equilibrium. Okay, so when things are in equilibrium, there are forces which are balanced. Okay, when the forces are balanced, so they also balance energies. Okay, just like you all are sitting here. Okay, so when you're all sitting here, so what is happening, that in the chair that you're sitting, you are not depressing down, you are not falling down from the chair. Why? Because whatever is your weight is the exact amount of reaction that the chair is also putting on you. So that is the whole reason that you are staying put in a particular position. Okay, but because of the height you are right now from the ground, if I remove the chair, all of a sudden, what exactly is going to happen? You will fall down. Why is that motion? Because of the height. That there is some amount of height which has a difference with respect to the ground and with respect to your position. So this difference in height gives you a kind of energy which is called as potential energy. Meaning this energy is right now not used in any way. But if any chance is given for any kind of disturbance, this is the energy which is going to come into picture. So that is what I am saying, that if I pull out the chair, okay, while you are sitting, I pull out that particular chair. So what is going to happen? Although you are sitting, you would tip down. So that change in the height actually is called the conversion of your potential energy to kinetic energy. And what is kinetic energy? The energy which is actually produced during the motion. Whatever you have in your body during the motion is called as kinetic energy. So right now when I'm speaking, I'm walking, I'm moving my hands, all of these are kinetic energy. Right now when you're sitting, because you're not doing anything, so you are right now having potential energy. And whenever you move your hands, whenever you move your you can say eyelids, whenever you are trying to, I mean, just twist your neck, every time this potential energy changes into kinetic energy. Had it been the case that you don't have this energy, imagine someone who is at the bed, someone who's bedridden, they don't usually have energy. Why? Because first of all, they are not able to eat. Okay, and because they are not able to eat, the energy which is actually there in your body, which comes out of digestion, that is actually not there with you. So it is very difficult for them to move. You might have seen that someone who's recovering from, let us say, a very severe accident where they crashed their bones of legs or maybe hands. So after their recovery, the first thing they go for is physiotherapy. Why? Because your hand or your leg has completely forgotten its natural movement. Okay, so you need to move. Your muscles need to be straightened out, or they must be flexing in a certain way. If they don't, you will not be able to move. Okay, so that is why what happens is that if you are lying at a particular position, okay, you become at an equilibrium with that position. And if that position is changed, okay, someone who has been lying down on the bed and now that position changes, if you make that person stand up, they will not be able to move. Okay, why? Because the energies have changed, but your body resists that change. You are not able to apply that force. Okay, so that is basically what is the concept of energy. So energy is basically what you apply for doing any kind of work. Okay, you want to lift this pencil, you will want to lift this, you want to lift your bag. You can only do that when you have energy. Okay, so that is why energy is basically the basis on which you do any kind of work. Okay, and work basically happens when in terms of physics, when you are actually trying to displace an object from one location to other. Just like you have your bag at your home, you carry it here. Okay, so your bag actually is displaced from its position at home to this particular position. Okay, so that distance, the shortest distance will be considered as displacement, and whatever force you are applying, so that force will be, you are actually balancing the weight of the bag on your shoulders. Okay, so that is basically the force. So when you multiply these two, we call that as work. Have you ever seen that all of you have traveled via train? Okay, so you might have seen, either you might have done it yourself or you might have seen some travelers who actually travel with a lot of luggage. Okay, so what basically happens is that when you are boarding or deboarding a train, what happens? You would require the help of porters, coolies, right? Have you seen how the coolie holds that particular luggage? The coolies are going to hold the heaviest of the luggage on their head, and some of the bags they are going to take it on their shoulders, and then they'll move. Have you ever wondered why is that so? Ever wondered that? How many of you go to gym, or how many of you work out with some kind of resistance band or something? None of you? You do. What do you do in gym? What kind of exercises do you do? Do you do power training, any dumbbells or something? You do strength training with war ropes or what? Okay, you do it with dumbbells. What exactly do you do with dumbbells? You will do curls. You will do curls, right? Next time, what you do? Hold your curl. What do? You do normal curls or you do hammer curls? Normal curls. What you do is that next time, first of all, when you're lifting up, let us say this is your dumbbell. Okay, I'm going to tell you the secret for bodybuilding. Okay, so mind that. See, if this is your dumbbell, okay, so grasp it in a neutral grip, not pronated, not anti-pronated, in a neutral grip. And next time you go down, okay, when you're coming up, let it come up in natural pace. But next time when you go down, take it as slow as possible, because this is actually the motion in which you're working against the gravity. And when you're working against the gravity, that is the point when your muscles actually stretch out to the maximum. But what I want you to do is that instead of doing that, just hold your dumbbell at 90 degree, a little more than 90 degree. Just hold it there, and let us see how long you hold that. You could do the same thing while making a kind of wall sit. Okay, meaning that you actually put yourself against the wall and you try to sit like you're sitting in the chair and hold that position. You'll get to know that within seconds, your thighs, your hips, your back, everything will start shaking. The same thing happens with all of those who do planks. You can't hold that for a long period of time. Despite the fact it is your own body weight, you'll not be able to hold it on. Why? Because your body, every single part of your body has a different center of mass. Okay, and that center of mass is actually the point where weights application happens. So that is why, imagine when you're doing a push-up. So in push-up, basically your body should be like this, but most of us have our bodies like this. Our tummies actually go a little sagging. Why? Because that is the center of your mass. Come, 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 I was waiting for you. You just don't know what we discussed about you. So today you're gone. Okay, so what happens is that instead of this, if you're seeing this as a straight line, you sag. This happens with most of us. Why? Because your center of mass is somewhere near your stomach, naturally. But this is what you actually are told to control in the gym, that instead of sagging, go straight. Okay, and this is also true for Surya Namaskar if someone does that. So basically what happens is that you try to balance a lot of different eccentricities in your body. Okay, so there are a lot of points where the mass is more. So because of that, what happens is that the forces applied there are more. That is the whole reason you are not able to hold yourself in that position. But still, let us say you hold yourself. Okay, you start vibrating. Why? Because that potential energy needs to now somehow be dissipated. That vibration is basically what is known as the change in the energy. Okay, a similar thing will happen here as well. Here basically what has happened, instead of you imagining yourself wall sitting, right now there are two rocks, okay, which are going to have them, you can say, overlapping each other. They are resting one over the other. Okay, that is how they are resting. Now basically what happens is that both of these rocks have a tendency to move. Why? Because they are not joined. As simple as that. They are not joined, so they will have a tendency to move. Just like, let us say you pour in, on the surface you are pouring in a cup of sand. So what happens when you pour in the cup of sand? The sand particles will spread out, they will make a cone. But the point is that they will keep on moving. Okay, and there is a certain location or a certain position in which they all lock together. Right? So basically what happens in this particular regard, we see that this is basically the concept of friction coming into picture. So everything can be held together using friction, but only in certain positions. That is the whole reason why rocks are also held together by friction. And if the friction is going to be overcome, if you overcome the friction, you will be able to move. Okay. Now, how to overcome this friction? Because rocks do not have any kind of addition towards itself, they also do not have any kind of force acting on them. The only natural force that you can figure out is basically weight. Okay. But weight actually is going to push one rock against the other. And when one rock is pushing against the other, that is something which will increase friction. Okay. So now what is going to happen? If you need some kind of movement, there needs to be some kind of pulling action happening somewhere. Okay. And this pulling action is what you known as tectonic force. Okay, which we'll be studying in the next chapter as well. So tectonic forces basically cause the rocks to actually pull apart, or they will be pushing each other. Okay, they will be either driving into each other or they will be pulling each other apart. In both of these, what exactly is happening? There is relative motion between the two rocks. And whenever there will be relative motion between the two rocks, friction is going to oppose this motion. Okay. So long as the friction is actually able to oppose this motion, it will not move. But once the friction is something which is overcome, there will be a sudden movement, a sudden disengagement. And as soon as there is a sudden disengagement, what is going to happen? The energy of this motion is going to be dissipated in the form of waves. Okay. Just imagine that you are actually traveling in a crowded train or a crowded bus. Okay. And they are moving at sufficiently high speeds. Suddenly they break. What happens? If they suddenly break, everyone gets a jostle. Every single person who's not holding, the persons who are not holding may also fall down. But even if you're holding on to something or you're sitting, you'll still feel that jostle. Right? Why? Because there is a sudden jerk. This is exactly what happens here as well. Okay? And that sudden jerk is going to be transmitted in all the directions. And that is something which is known as seismic waves. Okay? So waves in physics are a manifestation of energy. Okay. So just like the light that you are seeing, this is also a kind of energy. Okay. But when we talk about the light which is actually allowing us to see, okay, in this particular regard, it is called as the wave nature of light. If I increase the light, increase some more, if I add some more lamps, the brightness is going to increase. Okay. So that is basically called the wave nature of light. Light has two natures, wave nature and particle nature. This is something that you do in quantum mechanics. Okay, but the point being that whenever you talk about waves, so imagine the same waves that are there at the sea. Okay, they will come and go, they will come and go. But the point is that this movement of water is actually driven by air. It is not water's movement. It is because of the air which is moving over water that pushes this towards the shore. Okay. So that is actually the visualization of how air is moving towards land, and that pushes the water ashore, and then that water recedes back. The water is receding back on its own, but when it is coming to the shore, it is because of the push of the winds. Okay. So energy is dissipated in the form of waves. Okay. These waves are known as seismic waves in case of earthquake. Is there any doubt till now? Could you understand the basic physics? Okay. So what basically happens is that whenever there is going to be an earthquake, the earthquake waves are going to travel across throughout the body. Okay. In the interior of the earth as well, and at the surface of the earth as well. When it is at the surface, so what is going to happen? You are going to find something known as you can say that is called earthquake, because this is something that you are actually able to feel. If it is traveling inside the earth, you will never be able to feel it. Okay. So earthquakes become discernible only when they are found at the surface. So when you have a perceived vibration of the surface, only then you say there is an earthquake. Okay. So as long as you are in Karnataka, God forbid it happens, because this is one of the most stable landforms of the world, Deccan Plateau. Okay, you are not going to experience it. But go to Delhi, go to Nepal, for that matter, go to Assam, go to Pakistan, China, Afghanistan, a lot of earthquakes. lot of earthquakes. Okay, in Delhi itself we get at least 3 to 4 jolts every year. Sometimes they are so strong that in the middle of the night we have to jump out. Not like any destruction, but yes, it does scare us. Okay, or if you live in any of the mining zones, anyone who comes from the mining zones of Karnataka, what is mined there? Okay, that Chitradurga, Dantadurga, yeah. Okay. So you might have experienced blasting, yeah. So in blasting, that vibration you have experienced, yeah, the same thing happens here. So then you are not going to scare of earth. All of those who come from those mining areas where iron ore is mined, for cement industry is there, bauxite industry is there, you are not going to feel it because you have already felt that. And why is that happening? Because of a dynamite. Okay, so there has to be a force which causes the rocks to move. With respect to mining, that is an explosive, a controlled explosion. But when you talk about earthquake, that is uncontrolled. You don't know how big a chunk of rock is sliding over what kind of rock. So that is why the energy release here is several times more. Okay, that is why it is something which spreads out over a long range. Okay, so we are going to study that. Chalo. So what exactly are seismic waves and how are they formed? Seismic waves are the way in which any kind of vibrational energy from the earth is going to be released. Okay, so what happens is that this is something which is released in a lot of different types of scenarios. The primary source of seismic waves is earthquake. Okay, so whenever there will be an earthquake, there will be a slip between two of the rocks, and this slip actually causes there a lot of breakage in the interface. Okay, and that is something which is going to release energy. Second, when you talk about volcano, okay, so yesterday also I told you volcano is something which keeps on building and building before it actually explodes. So whenever there will be an explosion, it is going to cause vibration of the rocks. That will also cause your seismic waves. Next, mining operations. Okay, mining operations, for that matter, whenever there is any kind of underground nuclear weapon detonation, it will also result in significant amount of release of energy, and that also causes micro tremors. Okay, so most of the times when we are able to detect an underground nuclear weapon explosion, that is basically detected using the seismic studies. Okay, many a times you might have heard this or somewhere in the internet or maybe in the newspaper that we basically have got North Korea, and they basically have tested a new you can say a nuclear weapon, and this was an underground nuclear explosion. How do we get that? From the seismic wave studies. Okay, so these are basically the various waves. So what conclusion can we draw from the seismic waves? They are a manifestation of any kind of rapid and sudden energy release, but they are not limited to earthquake. They can be released from earthquake, volcanoes, underground explosions, mining operations, and even when certain dams fail, you will get the you can say seismic waves. Okay, when you actually visit any of the hydropower plants, okay, if you ever visit a hydroelectric power plant, so what basically happens is that we have a very strong current of water actually driven into the power plant. Okay, so there is a fan which we call as turbine, which actually is rotated because of the force of water. So when it is rotating because of the force of water, what happens is that that causes a lot of vibration. So and in the floor where the turbine rotates and in the floor where the water goes out of the turbine, there is a lot and lot of vibration. Okay, and that vibration actually always causes you to jump. Okay, now this is something which comes from my own experience. My own internship was in a hydropower plant. So you will just be jumping, you will not be able to listen to anything. It is so violent and rapid. Okay, even that produces seismic waves. Okay, so this is basically how you see seismic waves are not just limited to earthquake, and this is exactly what exactly UPSC asks. Seismic waves are produced only during an earthquake. Wrong. It is produced in all of these things. Okay, so here is exactly how UPSC tricks you. It wants to know how much you know. Okay, So shall we get ahead? Okay. Now, first of all, let us dissect an earthquake. Okay. So in an earthquake, what are the things that we need to understand? So first of all, when you talk about an earthquake is going to start in something known as a fault. Okay. Now fault is going to be a discontinuity between two different rocks. Okay. So see, whenever one kind of rock is going to be connected to other kind of rock due to friction, their interface, okay, their interface will always be dissimilar. In what terms? Both the rocks will have different hardness, they will have different surface, okay, they will have different chemical composition. So what happens is that because of this, they both, when there is an interface, that interface will always be dissimilar. Okay. Now what happens is that if we take into the account that as you go deep inside the earth, the temperature goes on increasing. Okay. Now when the temperature goes on increasing, all the rocks have different tendencies to react to this temperature. See, naturally everything whenever is heated expands. Okay. Naturally, if you give heat to something, it will expand. But the degree of expansion is variable in all of these. Okay. So what basically happens is that in this particular regard, we see that let us say these two rocks are, you can say, overlying each other. Okay. And there is a difference in temperature. So one of the rocks expands faster than the other rock. So in that particular regard, what is happening, let us say the upper rock is the one which is more susceptible to temperature change, it expands faster. This one expands slower. Okay. So what is going to happen, the one which is going to expand slower, it is going to resist the expansion of the top block. While the top block it is trying to expand, it would want the lower block to also expand with it. Now this friction is going to create motion. Okay. One wants to expand, the other wants to remain like that. Okay. This is one of the reasons of motion. The second kind of motion, they want to slide past each other because of the pulling or the pushing force. So if they want to slide past each other, so they are actually interacting in this entire face. A very wide face of the rock is going to be interacting with another wide face, and that is going to slip. So what happens eventually when you are actually applying this force, when let us say they are moving up across each other, they are moving apart from each other, something is steering them down. So what happens, they would want to move in this direction. Okay, ultimately the movement is in this direction, but the point is that so long as the forces are not able to cause this movement, they are only trying to, you can say, crumble the interface materials. All the materials in the interface are actually crumbling down due to this force. Okay, they are going to crumble down, and eventually when they both crack, when both of these forces and both of these surfaces are going to crack, so what is going to happen, they will suddenly move. And that is basically what you call as an earthquake. As they move, now their movement is not going to do anything, but the energy that is released suddenly, that is something which will travel as earthquake. So the point where this energy is released is known as focus. Okay. So focus or hypocenter is the point where the energy of an earthquake is released or it originates from. Okay. So where would you find the focus? The focus would be found at the fault. Okay. Now fault is nothing but a weak plane. Okay, write it down, then I'll tell you a lot of things. So focus is the point of release of the energy of an earthquake. Okay. The focus is located in the fault or in the fault plane. Let me know once you're done. Done? Now, when you talk about fault, so fault is nothing but a weak plane of interaction between two dissimilar rocks. Okay. So two rocks, wherever they are going to meet, that particular interface will be a fault. Okay. So fault is going to be that particular plane of interaction. Now, with respect to the surface of the earth, there is a particular point, and that is known as epicenter. Okay. So epicenter is the point on the surface of the earth which is perpendicularly above the focus. Okay. So from the focus, it is going to be exactly perpendicular above it. Okay, why? Because when you talk about perpendicular distances, they are the shortest distances possible. So wherever is the focus, from there perpendicular distance at the surface of the earth is called as its epicenter. Okay, so write that down. So epicenter is located perpendicularly upwards on the surface of the earth from the focus. So epicenter is the first location to receive an earthquake. Done? Yes? No, for one focus there will be one epicenter. There will be no more than one epicenter because there is only one point where your fracture will happen. Okay. Mhm. The focus, see, the shortest distance is the one which is taken as the focus, not the other one. Even if you take the curvature effect, the shortest distance. Now it does not mean it has to be vertically up, means it is always going to be up. It could be at the side as well, what you are trying to say. But the point is, with respect to the focus, that is also vertically up, this is also vertically up. Okay, so whichever is the shortest distance. Okay, so that is epicenter. So epicenter would be the first place on the surface to receive an earthquake. Have you written this down? Okay, now the distance between the two, okay, the distance between epicenter and the focus, okay, that is going to determine the depth of an earthquake. Okay, so the depth of an earthquake makes us classify the earthquake in two parts. One is called shallow focus earthquake and the other one is called deep focus earthquake. So now tell me from your own instinct, if they are very close together, at that particular time the disaster would be bigger, or when they are far away then the disaster would be bigger? What do you feel? When the distance between the epicenter and the focus, if it is less, the magnitude of earthquake should be more, or when the distance is more, then the magnitude should be more? If the distance is less, so that is what you figure out. Okay, so you should then understand that shallow focus earthquakes are more disastrous. Okay, why? Because it will take lesser time for the energy to come to the surface. So write this down as well. Okay, this could be an assertion reasoning question. Shallow focus earthquakes are more disastrous than deep focus earthquakes. Okay, now that is your statement 1, assertion 1. That is your assertion. The reason, it will take lesser time for the seismic waves to come to the surface. That is the reason for this. Okay, so the lesser the time, the greater the intensity, greater the vibration, and greater would be the destruction. So one clear cut question from earthquake which has not been asked yet, it may be asked. Okay, now when you talk about rocks when they are underlying over each other, okay, so they basically are called as plates, okay, or tectonic plates. In the next chapter you are going to learn about tectonic plates. Okay, so tectonic plates is basically a very huge collection of rock. Okay, very huge collection of rock, or a body of rock which is irregular in shape. It does not have a definite shape, no rectangle, circle, triangle kind of shape. It will have irregular shape, and it is the shape which is going to be locking with another of the tectonic plate. So this is basically how the tectonic plates are going to be locking together. Okay, because of the friction. So that jagged portions are basically what are the ones which will be having faults. Okay, is this understood? Now going ahead, what are the various types of faults? Okay, so faults basically have two rocks. We actually are focusing our analysis on two rocks, one which is at the bottom and we say the other one is the one which is supporting it. So one is at the top, one is at the bottom. Okay, now with respect to the bottom rock, what is the movement of the top rock? In which direction is the top rock moving? That is basically going to tell you what is the kind of fault it will be. Okay, so we have three different types of faults. One is called as a normal fault, the other one is called as a reverse fault, and the third one is called as a strike slip fault. Okay, so these are three types of faults. So when you talk about a normal fault, so in the normal fault what happens? This is the rock which is supporting the top rock and this is the rock which is at the top. So in a normal fault, the top rock is basically the one which is going to come down, while the bottom rock relatively, because the top rock is coming down, the bottom rock is basically the one which is actually going up. Okay, so when the top rock is the one which slides down, that is called as a normal fault. Okay, so see here, this is the bottom rock, this is the top rock, it is coming down, it is going up. Okay, so this is basically a normal fault. Now the rock which is basically present on the top is called as a hanging wall rock. Okay, and this one is actually the supporting rock or the footwall rock. Okay, so footwall is basically the one which supports hanging wall which is at the top. Okay, so hanging wall is going to come down and the footwall is going to go up. That is normal fault. Okay, the reverse happens in the reverse faulting. In the reverse faulting, what is going to happen? The exact opposite. In this particular regard, the upper block, the hanging wall goes up while the lower block comes down. Okay, so the movement is this way. So see that this particular block, which is a supporting block, it comes down while this one goes up. In both of these situations, what you are seeing, that there is a difference in elevation that is created. Okay, why is that difference in elevation created? Because you find that the rocks are moving in relation to each other. So even if one rock is stable, the other rock is moving, even then the other rock is going to rise up. Okay, you are going to see that it is seemingly rising up. Okay, now the third type of rock is strike slip. Strike slip is as simple as you rub your hands. This is strike slip. That's it. Okay, so these are three different types of movements. Now when you talk about normal faulting or reverse faulting, they are the reason why we have plateaus. Okay, many plateaus have actually been created because of this movement. Okay, and what exactly does this result into? It actually results into exposure of some of the rock layers. Okay, do you see these rock layers getting exposed? Similarly, in this particular regard, here will be that particular phase. This rock layer gets exposed. Why? Because of the change in the elevation. What happens is that these particular rock layers are the one which actually have the minerals. That is why you say that in the plateau we have more minerals. Why? Because there is a difference in elevation, and this exposed rock layer is where you mine. Okay, so if you talk about coal, you talk about iron ore, they are basically found at the edges, or because of digging these edges you are going to find it in some region. Okay, so technically it is like cutting a cake. Okay, so when you cut a cake and take a piece out, then you are able to see the layers inside it. What exactly are the layers, what exactly are the dry fruits and the ingredients. Okay, so basically when you take out that cake, only then you will be able to analyze its interiors. So this is exactly what happens with respect to an earthquake. In earthquake there is no cutting of cake, but what happens is that there is a change in the elevation, and when there is a change in the elevation, the rocks get exposed, and these are the rocks which you are going to study for mineral composition, and then subsequently you are going to decide if you want to have any kind of mineral exploration here or not. For example, in India we have two different plateaus. We have one part which is known as Deccan Plateau, and there is another part which is known as Malwa Plateau. Okay, so Malwa Plateau is located in the regions of Madhya Pradesh, Madhya Pradesh, for that matter Uttar Pradesh, Rajasthan, that region. It does not have mining. But talk about Deccan Plateau, it is something which is rich in minerals. Okay, so that basically tells you what is the composition of that particular plateau. Okay, so unless they were exposed, you would not be able to figure it out. Where do you have to set up mining, where you don't have to set up mining. Okay, so that is why in these particular regions, when you talk about Gujarat, you talk about Rajasthan, you see most of the people are business persons, they are traders, they are not farmers. Okay, but you talk about the regions of Chhattisgarh, you talk about the regions of Odisha, maybe Andhra Pradesh, you will find a very large farming population. Uttar Pradesh, very large farming populations. Why? Because they have soils which are fertile, they don't have minerals. But as you come from, let us say, Chhattisgarh and Odisha, you also have significant amount of mining. So where there will be mining, there will be less agriculture. Where there is no mining, there will be more agriculture. Okay, and if both of them are not present, then there is desert. Okay, that is also one scenario, no? That is also there with India. Okay, so that is how nature balances itself. Okay, so this region which is endowed with a lot of you can say minerals, it is not endowed with sufficiently large amount of agriculture. Okay, Karnataka every single year faces a significant amount of districts which go with drought, right? That is a severe problem here. That is not a problem in Uttar Pradesh. That is not a problem with respect to Madhya Pradesh. Okay, why? Because there is rainfall. Okay, but if you want to talk about mineral development, mine development, industrial development, you are going to hardly find anything except for sugarcane industry. You are not going to find anything. And here you go, so many different types of industries. Okay, that is why when you talk about the regions of Rajasthan, you might be knowing about some of the tiles like Kajaria tiles. They all come from Rajasthan, because the only thing they can produce is construction grade stones. So that is why you have them. Tiles, sandstones, marbles. Marbles are very good here as well, where there is a very elaborate marble industry here as well. But these are the things that are their mainstay for the economy. Okay, so see how physical geography is so deeply related to what would be your economic activity. Okay, unless you understand this, you will not be able to plan out your minerals. Okay, and when you are not able to plan out your minerals, you will not be able to earn, and that is when you will start taking bribes. So don't do that. Read your geography well. Okay, so understood these three kinds of faults, right? Now this is basically a normal fault. Now these are basically purely for your reference purposes, what basically happens. So what we understand with respect to a normal fault is that with respect to the top block, which we call as the hanging wall block, that is the one which is sliding down, while the other block is sliding up. This can happen when we are trying to stretch things. Okay, so in this particular block or in this particular fault, the force that we are talking about is tension. Okay, so here we are going to have tension. Okay, so when you stretch something thin, this is something what is going to be what it is going to relate into. Okay, so like you have all had cotton ball candies, that pink color cotton ball. What exactly do you do? What do you see that particular person doing? They actually use a stick to roll that particular thing up, right? So when you're pulling that thing up, that starts curling onto the stick. Okay, that is the same thing happening here. Stretch it and things are starting to fall apart. Okay, so this is type of fault, that is normal fault. So normal fault is possible when there is tension, when you're pulling things. Okay, the next one is reverse fault. Reverse faulting happens due to compression. Okay, when the rocks are going to compress towards each other, it is going to result into reverse fault. So this is known as compression. Okay, so what do you find? The footwall block goes down, the hanging wall block comes up. Any issues? Okay, then the third one, when you talk about the strike slip fault. Now strike slip fault is basically happening when two plates are just grazing past each other. So basically it is like two vehicles, they are overtaking each other in the opposite direction. Okay, so when they are overtaking each other in the opposite direction, let us say that one is coming from your side and my side, one is going from my side, there is minimal amount of contact. Okay, so in that particular scenario we have strike slip faults. Okay, so unless the plates are too close or unless the vehicles are too close, they're not going to touch each other. Okay, if they're far apart from each other, only a little amount of interaction happens. Okay, but if they're close enough, then they are going to scrub across each other. Okay, so they do result in earthquakes, but these earthquakes are not going to be as devastating as the others. Okay, so that is basically known as strike slip fault. Okay, so now I guess you have understood what exactly are the basics of an earthquake. Any doubts? Clear? Okay, so now we are going to take a break. Okay, I'm giving it early today. See, it is only about you can say about 50 minutes. I'm giving you a break early today. Okay, so it's 12:19. Come back at 12:30, and then we start with this part: body waves and surface waves. Okay, when we do that, I will need you guys as volunteers. See, what I'm saying is that I do not want to do this with girls because I am really going to push them. Okay, so I really do not want to do that. I can push them. I can definitely push them. I can push them out of the class, but I can't do that to you. I am chivalrous, no. So that is why. Okay. So guys, be ready. You guys have to volunteer a bit. Okay. Then you are going to actually understand what kind of waves we are talking about. Okay. So I want to explain P waves and S waves via an experiment to you. Okay. So take your break, recharge, and come back. And in the meantime, if anyone has got any doubt, please let me know. things that I'm going to demonstrate on you. See, no partiality, but he only has only one weakness. That is a mechanical engineer. Yeah. So 3 more volunteers. Who's going to come? Okay, very nice. I'm very sorry about ladies. I'm very sorry. I told you I'm chivalrous, so I'll not take the volunteers from ladies. Yeah. Okay, one more. You are coming. Okay, one more. Yeah, please. You don't have to sit there, guys. It's okay. I just want him here because he'll be getting up more and more. Don't worry. You don't have to change your positions. Yeah. So right now, I would want you all, you 4, to come to the stage. Okay. And we can give them a big hand of applause because now they are going to be pushed. Okay. So now what I'm going to demonstrate is something what is known as a primary wave. Okay. So there's a primary wave and there's a secondary wave. Guys, can we get this a little down? Yes, come on, Shaktimans. Yeah. Easy. Yeah. Come. Hello, sir. So what we are going to now see are primary waves and secondary waves. So we are studying how waves travel inside the body of the earth. Okay. So there are 2 types of waves. One is called body wave. Body wave is what is generated when the earthquake energy is released at focus. Okay. So it will travel throughout the body of the earth. So when it travels throughout the body of the earth, it travels in 2 ways. One is called primary wave or P wave. The second one is called secondary waves. Okay. So for the primary wave purposes, I would want you all to stand facing that wall. Okay. One after the other. A little bit towards this side because that guy is going to be dashed into the wall. Okay. And all of you put your hands on the shoulders of the others. Yeah. Just trust that I am not going to push you very hard. Okay. So for your own self defense, just have a little bit of support here. Okay. So now this is basically how rocks are oriented. Okay. Their hands basically tell you that this is the bond between the rocks. Okay. So you can, have really solid grip on the other person. You don't have to, it's like you are depending upon them. Okay. Now what happens is that when the energy is going to be released, okay, so that energy is going to be like this. Okay. So what did you see? In which direction did I push them? I pushed them in the same direction. Okay. And when I push them, in which direction are they moving? In the same direction in which the energy is traveling. That is what is primary wave. Okay. And every single person, when I'm pushing them, you guys are very lazy that way. Na? So what happens is that when I am pushing him, what is going to happen is that some amount of compression comes here. Okay. And then subsequently, this guy, when he is pushing him, some amount of compression comes to his arms. Subsequently, that compression goes there. And this is how you see that after that compression, they come back to their same original position. Okay. So technically, when I'm pushing them, it is like this, and then when it transmits it ahead, it goes ahead. Okay. So that is called as compression and rarefaction. Okay. So rarefaction actually means that you're relaxing yourself back. So every solid object in the world has some amount of tendency of regaining its original position or shape. That is known as elasticity. Okay. So this is basically what is known as a primary wave. So in a primary wave, what happens is that this particular primary wave, when it is being pushed like that, it can travel through all the matters. It can travel through solid, it can travel through liquid, it can travel through gases as well. Okay. Now let's get to the second position. Now all of you face towards the camera and just have your elbows a little touch to the other person. Okay. Just a little bit of touch of elbow of one to the other. Okay. Now this is basically how you see liquids are. Okay. So in the liquids you see that they do not have a very strong bond in between them. What you saw in solids as holding them each other, that is basically known as the bond between the two. But here that bond is not so strong. Okay. So in this particular regard, when I have to travel, when I have to send any kind of energy in the liquid, okay, so liquids actually move by something known as shear. Okay. So shearing basically means these are all layers of liquid, individual layers of the same liquid. Okay. They are arranged one over the other. So what happens when they have to move? They will all move together. If they don't, then what is going to happen if I move him? Okay, if I give him a jostle like that, is that moving the other layer? So this is basically what happens. See, don't worry, I'm not going to do anything to you. Okay, so this is basically what happens. I am having the energy transmitted, but that energy is not getting to those. So that is why when you talk about a primary wave, okay, primary wave can, when I'm doing a primary wave is like this. That will still go away. But when there is a secondary wave, that is called a shear wave. So the shear wave actually travels like this. Okay, so the vibration is this way. Okay, and it has to move like that. So in the liquids we see that once I give it a shear, once I displace this layer, it is not going to displace them. Okay, but at the same time, now stand as we stand in a free kick for a football. Have you seen free kicks in football? Yeah. So stand it like that, hold your hands, interlock them together. Yeah. Now who's going to kick them? Okay, now this is the kind of bonding that you see in solids again. Okay, now what is going to happen if I move them? So some amount of movement is seen in them as well. Okay, now he is a bit heavy, that is why he is not moving ahead. I'll transmit it from here. Okay, yeah. So now what happens? What are you seeing? Okay, so now see how exactly is the energy going like this. Okay, but the movement is happening like that. Okay, so this is the way in which the energy is getting transmitted, and that is the way the particle is vibrating. Okay, so this is basically called as secondary wave or shear wave. So shear is basically the same action that you have with respect to your hands rubbing, when you are rubbing moisturizer on your face, when you are shaving. That action is actually when you are actually having one surface running parallel to the other. That is called as shear. Do you understand this? So now do you understand why shear waves or secondary waves can travel in solids but not in liquids? Now in gases, what is going to happen? You can leave them. The gases, they are going to be even more far apart. So the same thing, if I move him, will the same movement get transmitted there? So that is why secondary waves are not found in gases or liquids. Okay, they are only found in solids. But if I still push him, okay, the movement would be slow, but still it would transmit. So that is why whenever earthquakes happen, the primary waves are the ones which also cause some kind of rumbling sounds. Okay, so when the primary waves vibrate the surface, they also vibrate the air, and that is why sometimes earthquakes are accompanied by a sound that is called as a tremor sound. Okay, and that is because earthquake waves, which are primary waves, can actually transmit through gases as well. Okay, is this understood? This was a question in UPSC. In what direction is the energy transmitting versus in what direction the particle is oscillating? Okay, so when you see in the primary waves format, when they all were interlocking their shoulders, so what happened? The direction in which I pushed them, they were all going in that direction. So that is the property of primary waves. Okay, so in the same direction as the energy is going to be transmitted, the particles are also going to vibrate in the same way. But when you talk about secondary waves, the energy is transmitting like this, but the particles are moving in this way. Okay, so there will be a perpendicular relation between the two. Is this understood? Yeah. Thank you so much, guys. That is what I wanted to do. You are sitting here. All the others, you can take back your position. Thank you so much. So now just let us quickly characterize this. On what? Still not able to get it. Okay. On the table. There you go. Okay. So now let us, yes, sir. So now basically we are learning about the primary waves. Okay. So primary waves are the first kind of body wave. Now you guys understand how hot it becomes here. Okay. Why I sweat so much? It is because of the heat you are finding here and because of the lights here. It becomes very hot. Okay. That is why I say please switch this off. Okay. So now what happens is that In primary waves are the fastest kind of waves. They are the first waves to be produced when earthquakes happen. Okay, they are the first waves to be produced when earthquakes happen. They are the fastest of the waves. And how exactly do they travel? They travel by compressing the rock and then expanding it at one part. You will compress it at one end, you will expand it at other. Expansion basically means it will come back to its original position. But when it is transmitting, it will also push it ahead. Okay, so that is basically what is a primary wave. I gave you a live demonstration, so we are not going to do that. See how these transmit. Okay, so in some of these, you just focus on this part versus this part. Are you seeing how the rectangles have their shapes distorted? Okay, so there is a series of compression and something known as rarefaction, and this is basically the region where the earthquake wave has not yet transversed. So there everything is symmetrical. Where it is transmitting, there you are going to find this distortion. Okay, so this is exactly what I wanted to demonstrate with respect to all of you standing here. Okay, so in the same direction where the wave is moving, the particles are also getting compressed in the same direction and then subsequently expanding. So can you tell me one thing, if the particles are you can say compressing and expanding in the same direction, what exactly is the physical property that can change with respect to the particle or the solid? The only thing that can change is its volume. Okay, when you are compressing it or expanding it, what is going to happen? It is going to change its volume, and when the volume is going to change, what changes? The density. So that is why what happens is that when you talk about the primary waves has an effect of changing the density or volumetric composition or volumetric arrangement of the rocks. That is the only thing that it is going to do. Okay, that will be the impact of primary waves. So these are basically your pointers to primary waves. These are the fastest, and that is why they are the ones which can actually be reaching the surface of the earth very early. Okay, the second thing, they travel through a series of compressions and expansions. Okay, so that is why they are also said to be similar in function like that of the sound waves. Okay, so that is basically sound wave. The third one, they can travel through solids, liquids and gases. I think now you are sufficiently clear about this. Why exactly are they able to do this? Okay, because it is easier, or you could still compress or expand all the three states of matter. That is why this is something which can travel through it. Okay, then subsequently what exactly is it going to cause? Because of the continuous expansion and compression, changes in density. Okay, and subsequently the objective what we found is that the way in which we are going to push in the same direction, the particles or the rocks are going to vibrate. Okay, you have to endure some more and then you can go back. Okay, if you feel warm, just let me know, then you can go back now. Done? Shall we go ahead? Writing it down. Right. Is this clear with everyone? Any doubts? So please don't get your questions wrong in the examination using P waves and S waves now. Okay, the second thing, secondary waves or shear waves. I have just told you what shear is. Okay, it takes 4 years for us engineers to understand what is shear, but then ultimately we realize what exactly is shear. Okay, so shearing can be visualized in two ways. One, I have just told you, when you are moisturizing or you can say shaving your cheeks, that is one way of shearing. The other way, when you are actually drying your clothes, so when you twist that cloth, that motion is also called as shearing. Okay, so there are two ways in which shearing can happen. Okay, one is that you basically are rubbing your two surfaces parallel to each other. They can run parallel like this, they can also run parallel like this. So both of them are going to produce shear. Okay, so this motion is what you produce when you are drying clothes manually. Okay, this motion is what you produce when you have moisturization, shaving, any kind of grooming activity happening. Okay, for that matter, when one of the best examples is when you put on makeup. Okay, so when you use, what is that called? That, no, that is a brush. What is that foam thing called? Those are small egg-like foams that come, no, colorful. Yeah. So when you use that, how exactly do you use it? I have no idea. But however you use it, it actually has a wedge surface. It basically has a wedge kind of surface. Okay. So that is something which actually I think is used for finishing purposes or applying something. What is the use of it? For applying something. So basically when you apply it from that edge or from the curved portion. Okay, so both of them are used. So in any case, what is going to happen is that they are actually going to, I mean, it is going to exactly contact your surface in a parallel fashion, right? So that is exactly what happens with respect to shearing. Now, how exactly a shear wave travels? Okay, so when the shear wave travels, it travels like this. Okay, so when it is traveling in this particular direction, but you find that the particle is going to oscillate in the perpendicular direction. Okay, just like when I actually jostled them like this, giving them ripples kind of waves. So energy was transmitting in this direction, but they were vibrating in this direction. Do you understand that? Okay, so that is what is S waves. Okay, or secondary waves or shear waves. Now these are basically the waves which are going to be formed after the primary waves. These are the second kind of body waves that are formed. Okay, so see how exactly is the movement of the rocks. Okay, how the movement of the rocks happen, and now subsequently this is how the wave is going to be transmitting, but the particles are going to oscillate in the perpendicular direction. So that is why these are basically the ones which are known as secondary waves. Understood? Okay, now when you talk about them, one of the most important aspects that we know about them is that they can travel only through solids. We have just seen why they can travel only through solids, because solids are the only surfaces or only state of matter that can resist shearing. Okay, when you talk about liquids, when you talk about gases, they cannot resist shearing. Okay, so what is going to happen? Just like when I tip this bottle over, you can see the this is basically called as the meniscus, the top layer of water that you are seeing. As soon as I tip it, it starts flowing. Okay, so what basically it means that the layers which are here of the water, whatever are the layers of the water here, they are not solidly joined to each other, they are not rigidly joined. So that is why when I tip it, the upper layers are the one which get deformed. Okay, so that is known as shearing. Okay, so liquids and gases cannot withstand shear, but if I do this, it is not going to deform, it is still shearing. Why? Because my hand is parallel to the surface, it is still shearing, but the point is it is not deforming, it is moving as a single body. Do you see this difference? Everyone is clear with this? See, this is one of the toughest part of physical geography to make people understand, and if you are understanding it, kudos. Okay, so what basically happens is that these are basically the ones which can travel only through solids. Okay, then at the same time what happens, because they are vibrating the particles in an opposite direction or in a perpendicular direction, they actually result in displacement of the particles. So because of this, what happens that there are elongations and compressions in various parts of a solid. Okay, so subsequently what happens is that this is something which induces a particular phenomenon known as fatigue. Has it ever occurred to you, have you ever attended any or organized any event in your college, or maybe any you have participated very deeply in any of the wedding related activities of your relatives, any one of you? Either you have organized a fest, any kind of social gathering for your home, or a marriage, anything that you have done? Marriage, okay. Others? Fest, marriage, college fest, sports tournament. Don't tell me your cricket tournament. Okay, good. Kabaddi? Okay. So that should be your annual college sports fest, no? Okay, 3 months. I should be in your college then. Yeah. So all of you guys, you don't do anything. VIP culture, marriage. So you must have worked dedicatedly in one of these, any kind of social gathering, okay, that might be from your home thrown away as a party, okay, for that matter a function, any kind of puja, okay, a marriage, a college fest, doesn't matter. You know that when you are actually working on that particular fest or that particular organization, when in organization in the sense when you're organizing something, you are the most responsible person. You are supposed to be knowing a lot of different things there, okay. There would be your juniors or maybe say some other people who are going to heckle you for that, but you are supposed to be finding a way out, right? So technically it means that till the time this function is not completely over and not completely winded up, you are someone who will be at your toes. Imagine yourself 1 hour after that, how would you feel? Now tell me your reactions. How would you feel 1 hour after you have, I mean, completed the entire work and now you have sit down? What is your feeling? Relaxed or exhausted? I would never feel relaxed. I would be like the Tesla motor where the charger is gone and I'm like, done. Done for the night and done for the week. Okay. So what is that? That is fatigue. Fatigue is the one that makes you fall instantly after a very long exhaustive day, okay. And that is why fatigue is not something that you will be sustained for a long period of time. From the first day onwards I've been telling you, don't push yourself too hard, your body will not be able to take it. Why? Because your body is going to go into the rebel mode because of fatigue. Your body is not used to it. So if you want to get it used to that particular kind of thing, you will have to do it gradually. Now imagine any individual who is actually working as a construction site laborer. They have very enormously laborious and physically demanding work in physically demanding circumstances, okay. Very high heat, high temperatures, exposure to sunlight, okay, dehydration, everything is there, but they don't do it the first day. Now imagine you going and standing there, just standing there, not doing a lot of things, just standing there and directing them to do things. By the afternoon your battery would be dead. Why? Your body is not used to it. And if I want you to do this for the next 1 week, and on the third day you are going to call me and say, sir, I am going to a doctor, I am not able to do this thing. That is fatigue, okay. So fatigue basically is an immediate, instant failure of your capabilities in the sense your physical self, okay. You will not be able to bear that kind of stress for a long period of time, okay. What you're doing now, you could overdo this, okay. You might be sleeping at 11 o'clock in the night, you may gradually take it to 12:30, you may gradually take it to 1 o'clock, okay. But if I ask you that you sleep only 1 hour in your night and you do study all the 23 hours, you will not be able to do it. That is not possible, okay. And what is going to happen? Your body is going to show that reaction. You will fall ill, okay. You will start being forgetful, or you would instantly collapse somewhere. That is fatigue. Fatigue is when the material is not going to give you any kind of warning that it is failing. Failing basically means that the any kind of material, when it breaks, it is known as failure, okay. That material could be your bone, that material could be anything else. So if you know about fractures, you would know that it requires a very strong amount of force and a large amount of force to actually break your bones. It is not something which is very easy to do. So that basically means our body is able to endure a lot of forces, okay. If you are, let us say, if you are actually that karate madam is not here, I would have demonstrated it with her. So if you are actually doing something like mixed martial arts, okay, heavy amount of lifting, that is something where you are more vulnerable to such failures, okay. So what does this mean? This means that we need to be very watchful about our own capabilities. So is with the rocks, but rocks don't know this, rocks don't have brains. So what happens is that rocks continuously keep on enduring these vibrations, okay, and these vibrations continuously keep on changing their interior structure. And then what happens? Suddenly one day they are just not able to take it, they leave it. So when they leave it, that is when the rocks fail, okay. Now I am going to demonstrate something what is tension and shearing, okay. That is where you come. So when you talk about tension, your arm is gone. Okay. When you talk about tension, so tension is you go that side, you lean yourself that side. That is tension. That is tension. Okay. Now if I talk about shearing, how do I shear it? I shear it like that. I twist it more, and you see he starts moving. Okay, I twist it even more, that will fall, and he'll lose his elbow. So sorry. Okay. So what do you understand when you twist someone's arm or someone twists your arm? It is something which is very painful. Okay. But if someone is pulling your arm, was that painful? So what does this tell you? That someone is pulling your arm, someone is pushing it. You can take some amount of stress. But there is only a definite amount of rotation that your arm is able to tolerate. If I twist it any further, it is going to break. So this should tell you that solids, okay, they are weak in shear. They are strong in tension. They could be strong in compression, but they are weak in shear. The same way like your body behaves, exactly the same way the buildings behave. Okay, right now this building, it is under enormous compression. Why? All of these things, infrastructure, walls, okay, these air conditioning, our weights, my weight, everyone's weight is pushing it down. But the point is, concrete is something which is very, very strong in compression. Okay, it can take a lot of amount of load on it. But now imagine that the building at its base is fixed. It's in a foundation, it is fixed. Okay, and the top of the building is like that. Now when the earthquake is going to happen, the building is going to twist like that. And that is where the buildings are going to tear from the middle. So that is called a shearing. Okay, as long as there is this kind of movement of the building, that is fine. This kind of movement is fine. This movement is not fine, because this is going to be free. The top end is free, the bottom is the one which is rotating. So somewhere from the middle it is going to break. Okay, so that is basically what is known as shearing. Okay, now you can go and sit at your place. Okay, thank you so much. So that is basically how you talk about shearing. Okay, so shearing is going to induce fatigue, and fatigue is something which is going to result into premature failure. Okay, it will be a premature failure. It is, see, one thing is that you know something is failing. Okay, let us say that you feel that let us say you have a bag, okay, in which you have been using since your college time, and it basically is now very old, but it is still carrying the load that you wanted to carry. Okay, you are still finding that there are some threads that are coming out from the belt, but still it is able to do the job. Okay, now one fine day, all of a sudden what happens, it completely breaks from one thread. That is fatigue. Okay, but it gave you sufficient amount of time to see that okay, this is something that you need to repair or replace, but you kept on pushing, that is something which failed. Okay, now let us say you have a bag which can carry 5 kilos. Okay, and you basically are loading it with 8 kilos. Now what will happen? It will immediately burst. Okay, that is fatigue. Understood? So this is basically what we are going to learn. So S waves are clear. Okay, so when you talk about body waves, so body waves are basically the ones which travel within the body of the earth. Now when they come to the surface, they are known as surface waves. Okay, and when they are going to come to the surface, only then you would be able to feel that vibration. Only then you will be able to feel the earthquake. As long as they are going to be in the body, no issues with you. Is this understood? So when they come to the surface, they are known by a very dangerous name, love wave. Okay, one of the most devastating waves. I'm not going to go into the emotions of this, but yes, the most devastating kind of waves are love waves. Why? Because the love waves travel in this fashion over the surface like a snake. So when they are traveling like this over the surface, now you just imagine if any building comes into its influence, how is the building moving? The building is moving like that, and that disco dance is going to completely shatter the building from the middle. Okay, this is exactly what happened in Myanmar last year. Myanmar, Thailand, you might see that, I mean, there was one of the videos that basically from the penthouse suite of Hilton, Thailand, Bangkok. Okay, that actually started vibrating a lot, but right opposite to it, a building completely collapsed because this was something which was done using earthquake engineering. Now that building was old enough. Okay, so age, improperly designed buildings, okay, and underlying rock structures, all of them are going to result into damage. Okay, so here what happens is that it moves very rapidly, and when it moves very rapidly, just like what you do with respect to your war robes, okay, except for her, how many of you know war robes? Have you seen Mary Kom? No. See, there is a device in the gym, you might find this with a lot of people, that actually has two ropes. Okay, and these ropes, it's up to you if you want to coil them together. Yeah, that exactly is war ropes, or you just do it like that. Okay, so that movement that you're seeing, that movement that you see, that waves that create, that is basically how the rally love waves are done. Okay, so when you do that, what happens is that just the same way, twist it over the roads, it will be like this. Okay, and that is why you see whenever earthquakes happen, earthquakes always, whenever they are going to crack the road, they will always leave that same track. You'll find this very clearly in Indonesia. When the tsunami came in 2004, you'll find such cracks on the roads. That was basically love waves. Okay, so usually in the UPSC parlance we say love is always dangerous. That is an example. Okay, but nothing like that. Now the second thing, this is how it is going to destroy you, love waves. Okay, just see what is going to happen at the surface and what is going to be at the bottom. Nothing can resist this. Okay, so that is why what we do some amount of earthquake engineering. Okay, so that is what exactly we do. These guys are going to tell you. They are civil engineers, not me. I just know the mechanics. Okay, so what basically happens is that, what exactly is the kind of motion? The motion is like this, rotation. So if the buildings somehow are able to resist this motion, they will be safe from this thing. And how exactly can you resist this? You cannot resist this. There is only one thing you can do. You can move along that particular displacement. So why not have something on which the building can rotate? Okay, that is how all the underground, you can say bridges, over the water bridges are designed. They have some amount of rotation that is given at the foundation. That tolerance actually prevents them from these waves. Okay, so that is why you see in Shanghai there is a particular building that continuously keeps on rotating top to bottom. It seems very awkward when you look at it from a distance, but that is a marvel of engineering. It continuously keeps on rotating. It will have very different kinds of irregular shapes every single minute. Okay, so that is why even the people who live in the, who actually work in that building get confused on which direction are we. Okay, so that is why they all have you can say a kind of what you get that in the clubs, no, that kind of band, that entry band, that is actually GPS enabled so that everyone can be tracked. It has motion detectors inside it. Okay, so that is what is love wave. So see how many layers of rocks can it actually displace. Okay, and that's the surface. So older days we were not able to understand this, and that is why what would happen, that in the older days we see that we did not have anything that can prevent us from the love waves. Now we do have this. Okay, we can now make the foundation such that they can tolerate some amount of rotation, and that is why when the love waves come and go, it is not going to have significant amount of damage. Okay, now the second type of waves are called rally waves. Okay, now rally waves are basically the ones which are like waves. Okay, imagine that you are on a boat, on a lake, or maybe on a sea. So what happens? You are going to go like that. That's the way rally waves are. So the only movement that they are going to do, vertically up, vertically down. But what happens is that these are very long wavelength waves, very efficient at displacing the foundations. Okay, although it is getting something up and getting the other thing down, but what happens is that they can actually crack the rocks. Okay, so they are also efficient at destruction because they are more frequent and they are more long lasting. But the point is that because they cause only vertical and vertical movements like this, that something may go up, something may go down, that's the only kind of movement, not a lot of damage is expected. There could be damage at the lower levels, but there will be no damage at the top levels. Okay, and physical shattering does not usually happen. Do you understand this? These are Rayleigh waves. Okay, so this is basically how you see Rayleigh waves, wave kind of motion. So wherever it is going to vertically lift something up, the other portion is automatically going to be seen as a depression. Okay, that's the kind of undulations it makes. Okay, that is Rayleigh wave. Now talking about a seismograph. Now seismograph is basically an instrument that is used to detect an earthquake. Okay, so it's nothing very complicated. It basically is a kind of free hanging pencil with, you can say, a paper which is just touched on it. Okay, and this particular pencil is something which is directly attached with the ground. So it has a rod which is attached to the ground, and whenever the ground will vibrate, the pencil starts vibrating, and the pencil will have the same kind of vibration that it is feeling from the arm. Okay, so that is how you get this kind of graph. This is called as a seismograph, and this entire instrument is called as a seismometer. Okay, so what do you find here in this particular graph? You see the vibrations of a pencil. Okay, so there are certain groups which you find in the you can say graph. Okay, the first wave to reach the surfaces, P waves. Okay, so see, as long as there was no earthquake detected, it was stable. As it started vibrating, so you find this. Okay, so these are initial but shorter wavelength, short waves. Okay, these are not going to be very long waves. They are not going to have any great amount of deflection. Okay, they have small deflection. Okay, after an initial period of P waves, there comes a portion where it gets stopped. Okay, and then comes some greater vibrations. Okay, so the amount of deflection that you are getting is actually the vibrations. Okay, so then for some time you get some amount of waves which are known as S waves. Okay, and after that you see that there comes very you can say violent amount of vibrations, and these are basically the ones when the body waves are now coming to the surface, and as long as they are going to be there, they are not passing, it will keep on vibrating. Okay, so the maximum amount of deflection is what is used to determine the magnitude of an earthquake. So what happens is that a seismograph is actually going to record these vibrations. And when you talk about these vibrations, so these vibrations are basically the one which are going to tell you how strong this earthquake was. So it will just be keep on vibrating with the same frequency that it is receiving from the ground. So what do we see? That earthquakes are not constant. The waves are going to transmit all the way. Okay, so there would be some time when they would be having a lot of vibrations, and then once they pass away, the vibrations die down, and then eventually they will stop. Okay, but the time period for which this is going to continue, that is something which is very crucial. That is something which is going to create a lot of distress, you can say damage. Okay, so what basically happens in this particular regard, we understand that when you talk about, you were talking about Japan. Okay, in 2011, Japan had this particular vibrations for nearly 5 minutes. 5 minutes is a lifetime. Okay, in 2024, we had one such earthquake at the death of the night, and subsequently we all got scared at 5:30 am in the morning. Okay, in Delhi, this was the nearest earthquake that happened to the surface, only 4 kilometers down the surface. Okay, and at the heart of Delhi, in the near the airport of Delhi, international airport. Okay, and that actually vibrated the entire Delhi. Okay, although it lasted only for a minute, but that was the time when we actually heard the sounds of the P waves that I was talking about. Okay, that a very fast, you can say, kind of jet is flying over you, that kind of sounds. Okay, so those were the ones which actually we could hear at 5:30 am in the morning in the month of February. Okay, so all of us, we all ran outside, but then we realized, okay, we just had to do some warm up. We then all came back inside and we slept. What would you do? I mean, it's when you wake up in the morning and it's February time in Delhi, the temperature is still 10 degrees centigrade. No use. So those who wanted to smoke cigarettes, they smoked cigarettes. Those of us who wanted to sleep, we slept. And all the oldies, they started walking. so did our dogs. So that's the thing. Okay, so this is basically what is going to be the most crucial phase. Now, because I am telling that earthquake waves are going to travel across the body of the earth, so earthquake will be detected in multiple locations around the earth. Okay, there will be some locations where this deflection is going to be highest, and based upon these we are going to understand where the earthquake originated from. Okay, based upon those deflections where the you can say based upon those readings where the deflections were the maximum. Okay, so triangulating using 3 such locations, we are going to find out what exactly is going to be the epicenter of the earthquake. Rest all the places you are going to find these deflections, but at a lower level and shorter lived deflections. Only near the epicenter you will be finding long duration deflections happening. Is this clear? Okay, so that is basically what is a seismograph. Now we talk about earthquake shadow zones. So as I told you that we basically have the earthquake waves traveling throughout the body. But the point is the earthquake monitoring stations are also spread across the world. We have earthquake monitoring stations in the middle of oceans as well. Okay, no physical infrastructure, we have sensors. Okay, then we have you can say land-based earthquake monitoring stations. We monitor earthquake via satellites as well. Okay, so earthquake monitoring is round the clock global effort, not a specific country's effort. So now what happens is that when you talk about the reception of the earthquake waves, there are certain regions that receive the earthquake waves and there will be certain regions which don't receive it. Okay, so the ones which don't receive it are basically called to be in the shadow zone. So it is very similar to the scenario that, let us say, going back to the same example, that we have a bonfire lit up. Okay, and I ask you all to sit around it. Okay, now when we are sitting around it, let us say 1 or 2 of us could not find a suitable position to sit. Now what exactly are they going to do? They want to be a part of us, but they are not in front of the fire, so they will sit one you can say at one level back. Okay, maybe you can say just behind someone else. But what is going to happen? The person who's sitting in the front is going to receive the warmth of the bonfire, but the one who's just sitting at their back, they will not receive the same way. So that is known as shadow zone. Okay, so shadow zone basically means no reception. So it is like when you are traveling on a train, your family calls, where are you? Okay, they said where are you, you did not receive it. Or let us say you received it and you said I am at such and such place, they did not receive it. So that is called a shadow zone. Okay, so we talk about these shadow zones. So shadow zones are more like fingerprints of the earthquakes. Every single earthquake has a shadow zone, and every single earthquake will have a distinct shadow zone. Write these 2 things down. Every earthquake will have a shadow zone, and every earthquake will have a distinct shadow zone. No 2 earthquakes have the same shadow zone. That is why I call them, they are the fingerprints of you can say every earthquake. Okay, so basically what happens is that now, because we have understood that there are 2 types of body waves, okay, P waves and S waves. So wherever they will be received, that is where you would say that okay, we have detected an earthquake. Okay, but we have still seen that S waves have a major limitation. They cannot travel in liquids. P waves can travel in liquids, solids and gases. So P waves will be received at a much greater location, but S waves will not be received in all the stations. So that is why the shadow zones of the S wave will be greater than the shadow zone of P waves. Can you imagine this? Any doubts, man? Are you able to understand this? Okay. So when you talk about P waves and S wave, so S wave, because they have a limited amount of movement possible, they will be detected in those regions which are having the waves transmitting through the solid medium only. Wherever a liquid interface is going to come, S waves are lost. Okay, P waves are the only ones which are going to be found. Okay, so now let us talk about the P waves and S waves. So the orange regions which you are seeing here, the orange regions, this is orange color I guess. I'm not able to see what exactly is the color towards you. So these orange regions are basically the ones where P waves is going to be received. Okay, now this gray region which you find is basically the region where P waves will not be received. Okay, Now why exactly is this? When we talk about P waves and S waves, they undergo two or rather three types of movements: reflection, refraction, transmission. They undergo all the three things. Okay. When you talk about reflection, so what exactly is reflection? The rays are going to hit something and they are going to go back. It does not penetrate. Okay. Second is refraction. In refraction, what happens? When the rays go into a substance, they change their path a little bit and then they come out on the other side, just like all our glasses. So that here the light is actually undergoing refraction. Third one is transmission. Transmission may or may not require any kind of change in direction, but it is going to transmit through. Okay, just like when I talk about when we talk about anything that I am speaking right now is getting transmitted to you, no hindrances at all. Okay, but any person who's outside this room, this particular transmission is going to be small. Why? Because all of these, you can say, objects are going to absorb some amount of these vibrations, and that is why anyone who's sitting outside will not be able to clearly listen to what I'm saying inside. Okay. So similarly, what happens is that when we talk about P waves and S waves, they undergo all the three things. So that is why whenever you see that the earthquake waves begin transmitting, they do not transmit in straight lines. These are not straight lines, these are all curves, and that curve tell you that they are all refracting. Why is the refraction happening? Yesterday's application, that as you go into the depth of the earth, the density changes, the density increases, so you find that there is refraction. Okay, so because of this refraction, two things are going to happen. They are not going to travel in straight lines, that's the first part. The second, they will have different speeds in different media. Denser the media, faster the speed. You can say lighter the media or less dense a media, lesser would be the speed. Okay, so speed of waves, speed of P or S waves is going to be directly proportional to density of the medium. So it basically means that all the rocks have different densities, so will be the speeds. The speed of P waves and S waves are going to be different, and it is because of this difference in speed do we have discontinuities. Okay, so what do you understand from this first part? The P waves and S waves travel throughout the body, but they are not received at all the parts. Okay, the parts where they are not received are known as shadow zones. The second thing, they do not travel in straight lines, they rather travel as curves. Why? Because they undergo refraction. And why refraction? Because the density continuously keeps on changing. Okay, they will not travel at the same speed. That speed is going to be dependent upon the density of the medium. So whatever is solid, the speed is greater. Whatever is liquid, the speed will be lesser, and at the same time refraction will be greater. And because of this, what happens? You have a shadow. Because the refraction is too great, the you can say the rays which were supposed to be coming here, they actually got refracted here. So this is basically one such way. Instead of coming here like this, it went there. Okay, is this understood properly by everyone? So the shadow waves of P waves is basically 105 degrees on both the sides of the epicenter. Okay, on both the sides of the epicenter, they are present at an angle of 105 to 140. This is the shadow zone. So this angle is actually the angle made by this place with respect to the epicenter. Okay, so at this is basically the angle that we are talking about. Okay, so 105 to 140 degrees, that is P waves. Beyond this, you will be finding them, but at a much lesser quantity. See the number of waves getting emanated, see the number of waves getting received. So what does this tell you? that because they are traveling into multiple states of media or multiple states of matter, you are going to see that they are going to have dispersion, they will have attenuation, weakening or loss, whatever you want to write. So the P waves are also going to be absorbed into the various layers, and that is why whatever is the number of waves generated here, far few numbers are received on the other end. Okay, so that is why beyond a particular distance you will not be able to you can say sense the earthquake as humans. That instruments are going to sense it, not you. Why? Because we have a certain definite frequency above which we are able to feel the vibrations, not below that. Okay, just like when you are breathing in and breathing out, so technically your chest and your gut is actually expanding and collapsing, but that vibration is not disturbing to you. Okay, but instead of that, just imagine that you basically have to undertake an ultrasound. Anyone who has gotten an ultrasound of abdomen or something like that, basically there is a very strong vibration that comes up. Or for that matter, you might be talking about when you are going on a train or a bus. So vibrations are something that you feel, but your own breath you don't feel. So that should tell you that there is a minimal amount of vibration which above which we are able to sense it as vibration. Below it we are not able to sense it. Understood? Now the next part, S waves. See the great amount of shadow zone that you would have for S waves. Okay, like Amazon's smiley. Why? Because beyond this you have liquid core as the cover, and in the liquid you will not have S waves transmitting. Only in the regions where there is, you can say, the presence of solid mantle will you find these waves existing. So because of this great amount of shadow zone of S waves, were we able to conclusively prove that below mantle also exists a layer which is liquid in state. Okay, and that was proved by that the outer core is liquid is something which was proven by this great shadow zone of S wave. Okay, so despite that we have not gone inside the surface of the earth, we could conclude this. This is our inference. Okay, is this understood? So that is basically shadow waves. Now, this is something that you have already shown. I have already told you what exactly are the conclusions with respect to the body waves. Okay, that body waves will never travel in straight lines, they will travel as curves. Why? Because of continuous refraction. Okay, and then when you talk about the change in density, that is also going to change the velocity or the speed with which they are traveling. If they are going into a denser medium, they will travel faster. If they are going into a you can say less dense medium, they will get slower. Okay, and because of this comes something which is known as discontinuities. Okay, so discontinuities are actually you can say a study of how fast the waves travel in the various layers. Okay, so these things are basically the ones which are identified with respect to discontinuities. So it is seen that when you talk about the you can say the traveling of the P waves and S waves. So in this particular graph, what you are seeing is that this represents ground. Okay, this is the surface, and this actually tells you the depth, how deep you are inside the below the ground. Okay, so now what happens is that we see, and this part actually is telling you the speed. Okay, so this particular part is the one which is speed or velocity. Here it is written velocity, we can just go with speed as well. What happens is that we see that the lower layers are the one which are more dense. Check out the speed. When you are at a depth of about 300 to 400 kilometers below the surface, as you move towards the surface, what you are seeing that the speeds are constantly decreasing. Okay, here the speed is about 9 kilometers per second, and this one has a speed of about 8.3 kilometers per second. Okay, let us say at a depth of 200 kilometers, what exactly is the speed? So this speed is somewhere around 7.25 kilometer per second, and then subsequently this is somewhere around 7.9 kilometer per second. Okay, so you see the speeds have reduced. Go up, they reduce even further, but then again they start increasing. Why? Because beyond this, the density of the rocks keep on increasing. What is happening? You are actually traveling from solid mantle, okay, to liquid upper mantle, and you reach asthenosphere. Okay, so asthenosphere is molten rocks. Above that, you have solid rocks, so density increases. Because of the density increase, you see the increase in velocity as well. And then further, when you go towards the surface, the density of the rocks further decrease, and that is how you see the surface. At the surface, their velocities are significantly less. Okay, so this nose that you are seeing is actually a discontinuity. Okay, and discontinuity is basically known as Moho discontinuity. Okay, its name is Moho. So Moho discontinuity is basically present at the transition zone between crust and asthenosphere or upper mantle. This is the discontinuity that we have. Okay. Subsequently, we have other discontinuities as well. So the first discontinuity is basically between the continental side of the crust and the oceanic side of the crust. So oceanic crust is denser than the continental crust. Okay. So that is why the first change in density gives rise to the first discontinuity, Conrad. Okay, don't worry, this is the last slide, then you're going. Okay, so Conrad discontinuity. So the first kind of discontinuity because of the difference in density of continental crust and oceanic crust. It is known as Conrad. Then comes the next discontinuity, that is basically the transition from solid crust to asthenosphere and the upper liquid mantle. That is known as Moho discontinuity. Okay, now from this particular liquid or semi-solid mantle, you move into the solid mantle, the lower mantle. So lower mantle starts from a depth of about 670 kilometers. Here you have the next discontinuity known as Repeti discontinuity. Okay, then from this particular solid part of lower mantle, you go to liquid part of outer core. Again a change in density, you have Gutenberg discontinuity. Okay, and then finally from the liquid outer core to solid inner core, again a density change, you have Lehmann discontinuity. Okay, so these are the discontinuities which are there all the way to core. Write it down, then I'll tell you something interesting. Or if you want, you can take a picture as well. I have no issues. Not of me, of this. I'm a very private person that way. Now may I tell you something? Oh, sorry. Yeah. Done? If you have done writing, now look at me. There are so many names to remember, right? How do you remember them? Very simple. Imagine going to a market and finding your favorite food. Just imagine that. It's opportune time for food. Okay. What is your favorite food? Don't tell me something healthy, something unhealthy. Okay. Healthy food is foul here. Oh, nice. Biryani. Yes, more favorite foods? Okay, dosa. I'll still give you that because that is not something I eat every day. I can give you that. Then very nice. There goes someone saying good thing. Yes. And you have one favorite dish, not two favorite dish. Others also have to give. If someone else also has butter chicken, then one. You gave biryani. You gave tandoori chicken. Both of them are my favorites as well. But others, one was dosa, and then what kind of mutton? Raw mutton, cooked mutton, boiled mutton, mutton nihari. What do you want? Okay, pepper mutton. Okay, yes. Which kind of biryani? Good. I was about to ask the same question too. See, with biryani, I'm very passionate. It's an emotion for me. You can ask him. Okay. You guys would not have eaten that many biryanis that I have eaten. So that is a be very specific. Hyderabadi biryani. Which biryani? Don't tell me homemade biryani. You have to be specific. Malabari, Done biryani. You have Madrasi biryani. You talk about Hyderabadi biryani. You have Dakkani biryani. You have Kolhapuri biryani. You want more? I'll give you more. Yes? Dum biryani. Okay. So I'll give you Hyderabadi dum biryani. Okay. Then, very sorry about the veggies. I have very limited options on veggies, but still, your favorite dishes, please. Biryani. Which biryani, ma'am? Veg or non-veg? Non-veg. Chicken, mutton, fry. Chicken biryani. Okay. Meghna's. Okay. Meghna's has good biryani. Yeah. Ma'am, this one. What kind of noodles? What kind of veg noodle? Hakka, Singapore, Korean, raw ramen, Hakka noodles. Okay. There goes someone very interesting. Pani puri. Then my last two warriors. What does my shooter like? Okay, chicken tandoori. See, you have a twin here. Yes. Anything spicy? Green chilies? Tell me something. No. Anything that you like. See, one thing, I am a good cook, but I don't cook everything. So I'm very sorry I'll not be able to serve everything. Okay, but yes, still, tell me. Okay, think about it. I'll ask him. Sorry. Okay, finally, someone with something traditional. Yes, now you are the only person left. It's okay, say anything. Whatever you would want to have. Even peppered chicken would do. Chicken 65 would do. Pepper chicken. Okay. Imagine you are searching for it in the market. You're very hungry, na? You're searching for it in the market. Okay. So what is the first thing you are going to do when you're searching for it? You will look around. You look around in the market, and once you find that particular spot, pani puri. So target acquired. How do you acquire that target? Eyes. Right? So first of all, look and locate a place. So when you look at it from your eyes. Your eyes have something called as cornea. C for cornea, C for Conrad. Okay. Now that you have located it, it is only natural that you are going to go there. You go there and you start eating it. So when you start eating it, what is the first place you are going to place this food after you have it in your hand? Mouth. M for mouth, M for moho. Okay. Now after you have put your food in your mouth, you start chewing it and you swallow it. Now once you swallow it, it goes in your food pipe and it goes inside. While it is traveling inside, the first pair of organs it is going to get is basically it is going to pass through your chest. Your chest has got lungs. Heart and lungs. What is the job of lungs? Respiration. R for respiration, R for repeating. Okay. Then after that it enters your stomach finally. Okay. So this particular area, which right now for me is pot belly, that is basically called as gut. Okay. This area below the diaphragm is called as your gut. G for gut, G for Guttenberg. And within your gut is an organ known as liver. L for liver, L for lemon. That is how your food will travel. That is how discontinuities travel. Plain and simple. Okay. So next time, don't be confused with it. Okay. So now we end up our class today, and now you can go search for your food, have your food, and revise your discontinuities. Okay. So thank you so much. I'll see you next week.